In this video, we're going to walk through how you can do some real-world applications with linear equations. So the first question we're going to walk through is, suppose that when I receive good service at a restaurant, I tip $5 more than 20% of the bill. And I want to write an expression to represent how I tip good service. So I don't know how much the bill is, so I need a placeholder for it. And this is pretty much the idea of what we were doing in the last section, was that to figure out what 20% of the bill was. So we had that 20% of the bill would be 0.2 times the bill. And then I'm going to tip $5 more than that, and this will be my tip. So the tip is going to be 0.2 times the bill plus $5. Again, this goes back to, okay, well, what is 20% of the bill? So what is, that would be your x, is 20% of the bill times the bill. And so 0.2 times the bill will give you that 20% of the bill value. So this is your x. And then plus $5. Okay. So part B, having received good service, I tipped $11.97, and I want to know how much the bill was. So you're going to do $11.97, that's your tip, equals 0.2 times your bill plus $5. I'm going to subtract 5 to start with, so I get $6.97 equals 0.2 times the bill. And then divide by 0.2 on both sides. And you get 34 something. Let's see. 697 divided by 0.2 is 34.85. And so that's how much your bill was pre-tip. Okay, number 2 is to translate those words into a mathematical equation. So 3 less than 2 times a number is 11. So 3 less than 2 times a number. So 2 times a number minus 3. 3 less than 2 times a number is 11. And then we would solve this. You would add 3 on both sides. So you get 2x equals 14. And then divide by 2. So x is 7. Well, okay, so some tips for solving equations. Isolate the unknown on one side of the equal sign. You can do this by manipulating the equation somehow. Sorry, this is not scrolling with me. If you do something on one side, you need to do it on the other side as well. And then if your equation has fractions, rewrite everything in terms of rewrite everything with the same denominator, and then look at the numerators. Sometimes you have to use the distributive property. So we're going to do A, B, and C together, and then, or I'm going to do A, C, and E now, and we'll do the rest together. So for A, I'm going to distribute first. So I have 4x minus 36 equals 8x plus 24. And I don't know why that's not with me. There we go. And sometime it'll load the rest of it. Okay. And then I'm trying to combine like terms, so I'm going to move the x's to one side. I'm going to go for moving the 4x over, so I'm going to subtract 4x from both sides. So I have then, I'm going to write, I'll just do it right here, minus 36 equals 4x plus 24. I'm sorry, I don't know what's going on with the delay. I am writing things. I'll just pause until it's there. Today, sometime. No. Okay. Okay, so then I'm going to actually subtract 24 from both sides. Negative 36 minus 24 is negative 60. So I would have negative 60 equals 4x. And then dividing by 4, I would get negative 15 equals x. Okay, and then on C, I'm not going to have space to do that there, but on C, we have a common denominator on the right-hand side of this, so I'm going to squish those together as one fraction. And so I would have x plus 5 plus x minus 3 over 6. And that's actually going to be 2x plus 2 over 6. And that equals what we started with, which was 4x plus 1 over 3. So this is a case where I could write the 2x plus 2 over 6. I could write that with a 3 in the denominator and then just compare numerators. But say I didn't see that, I would just solve that with cross multiplying. So let me pull this down here. So I have 4x plus 1 over 3, and that's equal to 2x plus 2 over 6. And then what I'm going to do is cross multiply. So I would have 6 times 4x plus 1 equals 3 times 2x plus 2. And then, so I'm going to distribute this 6 and that 3. So I have 24x plus 6 equals 6x plus 6. And then I'm going to simplify that. I'm going to move the 6x over, so I'm going to subtract 6x from both sides, which would give me 18x plus 6 equals 6, and then subtracting 6 from both sides, I get 18x equals 0, so x is 0 divided by 18, which is 0. And then the last one I want to do is E. I'm going to distribute that stuff to start with. Let me change colors here so we don't get confused. So I'm going to distribute things to start with on both sides. So I have 20 minus 8x plus 10x equals 20 minus 6x plus 8x. And then I'm going to combine like terms. So negative 8x plus 10x would give me 2x. So I have 20 plus 2x on the left. And then on the right, okay, and then on the right-hand side, I have 20 plus 2x, because negative 6 and positive 8 is 2x as well. So I have 20 plus 2x equals 20 plus 2x, which is always true, no matter what x value you choose. So this is actually called an identity. And we will go through the rest in class.